and I can copy the files off of a Mac's hard drive. So does this make sense? So here's the other thing that's important. Mac drive is this little circular thing down here in the right hand corner. I don't know if everybody can see this. It looks like Simon Says. It's really a Windows symbol with an apple on it. So it's the Windows. So if you double click on that little icon, it will start this window up. Do you see this window? So if you double click on the little Simon Says in the next to the tray, you'll get this box. Everybody good? Click Mac options, the last one, change Mac's options. So a little box will pop up for the driver, and I can control the driver. And if you go to the second box called options, I'm going to show you there's this one item right here. So your file name, normal use, would be if a Mac has a tick or a tilde or something that we don't support in Windows, a character we don't support, then tough luck. Normal use would mean we can't copy our file to our hard drive. It's not going to let us. It'll basically crash if we try. Does that make sense? International use is the paging content, so all your code pages and all that stuff that will convert characters, it'll allow you to do that. Backup file transfer converts the character that is not supported on a PC to a character supported on a PC. So if a date is in the file name, so you get dates with slashes, PCs don't support that, so it will convert that to a dash. So you have to check that box if you want to copy files off of your Mac, because your name will not be the same. So if I open this up and I tried to copy a file like this from a Mac to a PC, I could do it, okay? So that way it converts the name on the fly. So it does change the name. It is making a physical change to your name as you copy it. But now I can do all the same things on the system that I would have done if it was a Windows system. So I can say change it to a flat view. I can look at icons. I can look at graphics. I can look at anything. And surprisingly, I've also done the exact same thing for Linux. I have a Linux driver that allows us to do these things as well. And so I can now use my tools to do all the work I would have done for any other operating system. So I've highly customized these laptops to get this done. So everybody good so far? Now the hard part, APFS. So the next Mac file system is called APFS. And it's the Apple file system. And right now, I wish I had a lot of good news for you. Right now, other than trying to struggle to mount everything and try to figure out how to get files out of the system, recovery is impossible. Currently dealing with recovery of APFS is fundamentally done on purpose for you not to recover the files. Their entire point is to make sure that you're a secure operating system and that you don't have access to things that are dead and gone, and most of the time it's on a solid state drive. I don't actually have a picture in here. I've got somebody who wrote my buddy Zoran wrote some material about it, and I wish I had good news for you. There is a file that describes the file system in depth, and I have it on the thumb drive. And so, what's that? Yeah. The thumb drive that I'm going to hand out to you, this one, it has a white paper on it all about APFS and how the APFS structure works. So the problem is that all the data is broken up into pieces, so you can't find the pieces. It tries to create some internal redundancy of itself in the file system, but it also is highly destructive. If you delete a file, it thinks you said so. Bye-bye. It's gone. It will destroy that data very quickly. And in forensics and in data recovery, it has become near impossible to get any of that stuff back. And all we're doing is struggling. And it's been a struggle for like a year just to find stuff that can even deal with it, mount it. See you later. He told me he was leaving early. He had something he had to do. So it's become a struggle to do that. It's really become a problem as a whole.
We had an agent about a year and a half ago. We tried to figure out which tools could actually image We found one.
Macquisition.
Samurai.
Which one?
Samurai.
Recon. They're that particular release, like they had just released it,
Yeah.
like that day.
Yeah, they sent it to us over.
Yeah.
They were like, "Here, you test it." I'm like, "All right, whatever."
Yep, I use Recon all the time, and
Pretty cool.
it was affordable. It's a lot cheaper than Macquisition, and Macquisition was late to the game.
They didn't even do it. They didn't even get to it.
Yeah, they did eventually get to it. Yeah, like 3 months.
Yeah, Recon did.
Right. Recon was already done. I got Recon like the day it was released, and we got 2 copies of it, and it was like $300. And Macquisition's like $1,600
Yeah, I know.
for an imaging tool.
I still use it.
Right, but so on Macs with APFS, that was the only way you could image them. There's still not a lot of great variety of ways to image a Mac. It's still, and I'm a little bit worried that means Macquisition is going to be dead now that Celebrite owns it. So.
I'd be surprised if they killed it off though.
It's one more
They
thing
might
for them to
integrate
sell.
it.
Yeah, well,
I can see.
That's what people said about Lotus 123 when IBM bought them. I'd be surprised if they kill off such a popular product. How about Lotus Notes? How about how about Borland? They got all the Borland products in the deal too, Quattro and all the others. How well are they doing today? I mean, near non-existent, right? So I don't know. You don't know, but how many times has a product been bought by another company and then done better? How many times does that happen? I'm not even sure if I know of one. Anybody? I mean, at least Symantec didn't buy them because that's where all good products go to die.
I know,
Right? There's nothing left after Symantec gets done with it. So, or CA. I mean, once they get done with it, it's gone. It's been piecemealed to death. There's nothing left. So, all right. So that's kind of my spiel on this. The only thing you can do on APFS, at least, is mount it and be able to try to see the file system and do something with it. There are tools that you can use to mount it. But as a whole, that's about the extent of it. Otherwise, APFS you want to stay away from for now until we build the tools that will do all the things that we previously want to. But because it was built around the idea of trim and the fact that it was primarily for solid state, because when you first got APFS, if you had a hard drive, it did not install. It only installed on the solid state drives, which was meant to help them last longer. When a file was deleted, it's deleted instantaneously, it's gone. So there is no repercussions or anything that you can do to get that data back whatsoever. You just can't get it. And then the phones were the first ones. The phones were updated before anything else, which went pretty flawlessly. I was again impressed that you have such a major update and a new file system was deployed on the phone overnight and had small problems. There were some people, but it was pretty rare as a whole. But and that's also exactly the same way why the iPhone, like iPhones being a Mac and being APFS, all of the apps and all the functions and the packages are identical on an iPhone as well as they are on a Mac. So very similar functions for the recovery, but just as horrible functions for encryption and trying to get back deleted data and things like that. The only difference is the iPhone uses databases to store data, whereas your Mac does not most of the time. So if it's in a database, you have a chance. If it's not in a database, it's not protected by anything, and you lose all your files. And just last week, we got access again to file systems, at least by what Celebrite released, using the Checkmate. All right. So any questions about the Apple stuff at this point? I am primarily not doing the recoveries of Apples on the Mac, though. I'm doing them on a PC. Most of the time, our studio does pretty good. Just don't do carving. I want to try to fix the file system. So we're going to get to the carving stuff here in a few minutes. And then we'll probably have to wait till tomorrow morning to do the RAID array stuff. But let's talk next about Linux, because I'm going to show you what your biggest problem is. Surprisingly, over time, so let's go ahead. Just really surprisingly, where am I? I will be on 145-ish. 145. Dun dun dun. All right. Linux actually has quite a few file systems, but they're just not primary anymore. There's quite a few different variations of Linux file systems, and the only reason that I'm really covering this, I will tell you, in all the years that I've done this, I've had maybe 6 Linux machines, workstations, in for recovery. Because either Linux people aren't going to spend the money, or either they are smarter than everybody else and they know how to back them up, or they have other methods to get past things. But it's pretty rare I get one in. Usually it's a developer's machine. It's somebody who developed something, it crashed while he was developing it, he didn't have a backup of it, and he wants me to recover it. Now, on the server side, still pretty rare. Most of the time they're typically robust. I've had a few of those. But the most I see it everywhere is in NAS boxes. Everything that you'd buy for RAID arrays or NAS boxes over at Best Buy or whatever else, or wherever they get it, that's where I see them, is somebody wants a recovery of a RAID array, NAS box, or something else. A variation of sizes, typically somewhere in the 2 to 8 drive range. And outside of that, I don't typically get Linux boxes. I get, once you get up into the higher end ones, you're looking at NetApp and other higher end RAID arrays that are harder to deal with. So as a small to medium sized business company that I deal with, and I deal with some large arrays, I've had quite a few that are 80 gig, 80 drives in the array, and a lot of NASs and sandboxes that have come in that I've had to do recoveries on. NetApp is the worst one of all of them because they're so custom that you cannot do it in software. They don't have any software that will do a NetApp server and recover it in the drive. Otherwise, I don't ever need the controller. I don't ever need your system. I can always do it in software, and I have the ability to hook up pretty much an infinite number of drives. I'm at a spot now where, and it's very easy to get there actually, surprisingly easier than you would have imagined. So let me address NAS boxes first, and then we'll get to the RAID array stuff. But this is why I'm doing it, because I don't see them on a normal day-to-day basis as a recovery machine. I see them because of the NAS boxes and the RAID arrays. There used to be Riser. Riser was a big file system for Linux for a while. It was a B tree. It was exactly the same layout as Macs. And they did not have the standard inode tables. So what would happen is, if you had a Riser file system, then it would be a B tree. It would look identical to the structure for a Mac, and because the inode tables are so dependent in Linux, they had to clone them. So what happened is they would make their updates in the B tree, and then they'd copy them to the inode tables, so that the inode tables would be dummies of it, and then that way if any other tool saw them or played with the inode tables, that it would be correct. So basically what happened to the MBR and cloning to the MBR, same kind of idea. So the reason Riser is no longer used, because it's very fast. It was the fastest of all of the file systems that they had for Linux. It was created by a guy named Hans Riser and open sourced by Hans Riser. Hans Riser made a deal with the government because he was going to be, he killed his wife and he buried her on a trail in San Francisco. And so he made a deal with the police in order to save his life so that he wouldn't get the death penalty of, I will show you where my dead wife is and where I buried her on this trail that people are jogging over every day for an exchange of that. And so we call it the murderer's file system. So that kind of does it in at that point. You don't really get a lot of people wanting to use it. There are additional versions of Riser. He open sourced it. It's all been released. Another group picked it up. So it's still out there. There still is options. It just has become less pervasive in the rest of the, and you can imagine why. Just, anytime that you've got a murderer as the person it's named after, it's probably not going to do real well. I mean, there's not a lot of Charles Manson restaurants around or anything like that. So so anyway, everybody went to, instead of, it used to be ext3, ext2, and Riser. Those were the premium ones that were out. Now it's ext2, 3, and 4. And those are the primary ones. Now, ext2 and 3 are the same. The difference is they added journaling. When you're doing recovery, you just don't use journaling. So you use ext2 tools to recover from ext3. Everybody good with that? So anything that you see that says ext2 recovery tool, that's the same thing. You're not going to activate the journal. So even in our studio where it says, it'll say, I want to recover from ext2 or 3 or 4. It doesn't make any difference if it said 3 or not. 2 and 3 are the same, so they're identical. They just have another label for it. Okay? So there isn't anything else. 4 is different. So you have 2, 3, and 4. 4 removed redundancy. So the problem is you have a RAID array and it's 30 terabyte. The tables, the inode tables, duplicate across the drive. They look like this. So the inode tables are similar to our MFT. So there's a cylinder group. You see the cylinder group here. This would be the structure right there. Your super blocks, your inode, and your data for your files and your structure. And this would duplicate. See how there's another one? So every partition has what's called a magic number. They look similar to prime numbers. And you go to those locations and you'll find a new cylinder block group there. And then it duplicates across the entire drive for however big your drive is, till the end of the drive based on these magic numbers. If you had to run a check at boot time, if you had to do FSCK and try to figure out whether or not everything was okay, it takes 24 hours for a 30 terabyte drive. So an hour a terabyte basically is what you're looking at. And so that's why in ext4 they remove some of the redundancy so there's less to check. So they have a primary table and they've removed the redundancy. So that's the only difference between them. Otherwise the rest of the tables and the content and the structure are exactly the same. The layout of the data is the same. So ext4 was meant for solid state drives primarily so that it didn't do as much damage along the way. Now everything about Linux still looks the same as it does as a Mac or a Windows machine. So if you have a file and you want to carve it, you can carve the file just like you do. It's raw data. Somewhere there's a table. Even though the file system looks more complicated and there's more to it, there's a lot more folder structures and things that are part of the operating system that keep you doing things. None of that matters to you as far as your recovery goes. Everything is a file. And the only difference between Windows and those is that a directory structure is a list of files. That's all that it is. So it's still a file. They're all files. So you can still carve them. They're raw data. You point to them and you carve them. Here's where your problem comes in. So these are called indirect blocks. There's direct blocks and indirect blocks. What happened when Linux was being designed and this ext file system was designed, we're talking 1993. We're talking a time when everything was a lot smaller and the content was a lot smaller. Block sizes were smaller. Hard drives were like 2 gigs. I mean, we didn't have big drives. That was the best we could do. So what they did was they broke the blocks up into sizes. And when you store a file, it stores it in those holes. When the file exceeds, and I think it's around 48K, when the file exceeds this block, now there's an indirect pointer, and surprisingly, it's still contiguous. The pointer points to the next location, and the next location usually is still right here and still continues on. So what happens when you carve a file is that the indirect pointer is included in the data. Does that make sense, everybody? So Linux tools, while the file system is mounted, know the indirect pointers, and that's how they get to the next piece of data. So they don't include it. So when you're using a Linux tool on a Linux drive, then it just parses it. It's kind of like fix-up bytes. It'll just be done, and you won't even need to know about it. It'll just be handled on the process. Well, not on a Windows machine carving a Linux machine. Even though, for some reason, our studio should know that the file includes an indirect pointer to the data, they can still include the data. Because when they're carving, they do FFD8, FFD9, and in between all that contiguous space is the pointer to where it would have continued on. Does that make sense? So once it exceeds a certain amount of data, So here's what it looks like if you carve. I'll go to it and show you. Blah, blah, blah. All right. So if I'm carving a file that's a photo on a Linux box using a Windows machine, RStudio specifically, because some tools do compensate for it, Xways compensates for it correctly. So if you have enough money to buy Xways, Stefan knew the pointer was there, he stripped the pointer out, and now you have a complete picture and it's fine. So Xways carves pictures correctly. RStudios does not. RStudios leaves the pointer in there and just carves FFD8, FFD9, that's it. And it's probably because the engine that they use to do that is also the same engine that they use to do everything else. So what they had was a database, and their database just says headers and footers carve. And so they probably didn't have a custom thing that says, well, I'm on Linux, and in this situation, do something slightly different. Does that make sense? So I think they still are just like, I can't fix that because I need to write a custom piece of code, and it's not going to throw everything off. So people think sometimes this looks like what happens in a RAID array. Because you know when you're recovering from a RAID array, you get the skewed pictures. And I'll talk about that and why you get the skewed pictures. This is not a damaged RAID array. I want your eyes to get to a spot where you see this and you know it's not a damaged RAID array. This picture is correct. This picture just has a pointer in it. And you can't manually remove the pointer. I need to get the OS running again. So if I have an entry, I can do that, or I can use another tool that carves correctly, or use a Linux tool. But if I got this far and I was reassembling a RAID array, and this is what I saw, and this came off of a RAID array, this is a correct picture. I have done all the work and it is correct. Now I need to take another step and go and mount my OS after I've repaired something, and I know how this RAID array works to get this fixed. Everybody good? So I need you to understand that's the difference between this and a RAID array picture is that, so you can see this, you can see that there's a shift, there's a bit shift, basically the pointer's here, and then it caused everything to slide. And once everything's off, color gets messed up. So color will start kind of okay, but later on, the further and further away you get from where the error occurred, the worse the color normally gets. So in a RAID array, it will be skewed quite a bit. So this is 100% because of this problem right here. So this all has to do with the data layout. And so as long as we can carve and get that far on a RAID array, even if it's a Linux RAID array, we'll be fine. I'm going to do something different for RAID arrays. I reassemble RAID arrays by photos. I think it's faster and quicker. Years ago, I had to come up, like you can use in RAID arrays, you can use a hex editor and you can calculate buffer spaces in between them and try to figure out where the RAID array goes. And RStudio wrote a book on it. There's some guys in the Netherlands that wrote a book on it. There's a whole process for how to do that. But I guarantee you in 45 minutes or less, you can reassemble it by photos. And you can see them graphically. You can just see it happen. There is zero chances, if you have a 2 meg photo, that you can reassemble that photo and be wrong. Your RAID array will be right 100%. There may be a second problem. There may be something else that happens. But if you have a 2 meg photo, you've done all the stripe sizes that are possible. If it's reassembled correctly, your RAID array is reassembled correctly. But I'll show you what the other choices and the things are that happen in between. So on at least a Linux box, this is what I'm looking at. Now, back to these pictures that I was skipping by. On a Linux machine, on a RAID array, unless he's a programmer, you normally do not need any of these items here. Now, some people who are workstation, they've customized their workstation and done printers and all these other stuff. They may want their var directory and they may want their etc. So they may want those 2 directories with all of their options in order to have their current configuration of their machine. If they're programmers, they're compiling stuff and replacing executables and trying to get things to work, so they may need the whole thing. If it is a NAS box, this stuff all exists in a ROM or flash somewhere, and it boots off of it and then makes a directory for the storage on a hard drive. So your hard drives are all linked together, and the box is just a dumb box. You plug it in, brings it up on the network. It's got a couple of things for login, and then every single thing that's shared is shared off of a home directory or a public directory. So they'll set that there, and then all the subfolders for every user will exist off of this. And that will be the only thing that you want off of the hard drive. That's what you're trying to get the data for. So when you see a hard drive that has that, you're going to be separating it from the machine. Okay? And I'll show you what that means in a minute, what we're looking at. So I think I've covered everything there that's important. You have indirect, direct blocks, and then I wrote a bunch of things about, so if I had to give you any advice about recovering Linux boxes for any reason, there's two sets of things that you need to know. There's the pre-2004 kernel, and then there's everything after the 2004 kernel with 2006 kernel, so 2.6. So when they went to the 2.6 kernel, all the drivers for the 2.4 kernel and earlier were now obsolete. Somebody had to rewrite them all. There is an opportunity here and there that you may want to go back to a pre-2.4 kernel and use the drivers for those, because old RAID arrays, no one ever rewrote the drivers for. So you have a server that has died that has an old RAID array. I would go back and find a version of Knoppix. Knoppix DVDs had all the drivers on them. And so KNOPPIX, they had all the drivers on them, and you could boot on that and recover almost anything. And so I do keep old CDs around to have all the old versions of Knoppix and then new versions of any OS or anything that you want today from that standpoint. But there was a difference in those two going backwards and forwards from that standpoint. So if I have to recover some, I will go get some of those old Knoppix disks and things like that. And then there are drivers. There are free drivers and things that you can do to deal with the images, and there are Linux tools. And pretty soon, Windows 10 is going to have all the Linux stuff in it. So we'll actually be starting to use Windows probably to do our Linux distribution stuff, rebuilds and things like that. So let me point out that in the machine that's in front of you, the guys at Runtime don't have a lot of tools that do Linux stuff. They did make a tool that was called Linux Explorer. It's a little bit like Disk Explorer for the other operating systems, but it's not real great. It has some bugs in it and has some problems in it. If I had to reassemble a RAID array by hand that is a Linux RAID array, one of the tools that I would use is called Captain Nemo. They have a version called Captain Nemo Pro, and it supports a variety of the file systems for Linux. And it's a very plain looking tool, so it's very, I'm going to execute it so you can see. There's nothing to it. This tool, just basically you could mount your images and you could run all your images through here, and it will deal with Windows, Novell, Linux operating systems and file systems, and the new version does APFS, I think. It does HFS and APFS. So at least from that standpoint, this would be a tool I would use. Now, here's the thing. It doesn't look complicated. There's not a lot of setup. If you want to do a RAID array, you don't set it up here. Their tools tie things together. So they originally, Runtime is one of the first programs that made what's called a virtual image. It's really an XML file. They created XML files to track disk organization. So you can make an XML file and put it in this file inside of this tool, and it will help you reconstruct the RAID. They have a tool to help do that, which is called RAID Reconstructor. So this tool makes your virtual files that you can then take complicated RAID recoveries and put them in there. So if I'm doing a NAS box, I just want you to remember, at least at this point, because we can run through this, especially if we're going to do it in the morning, we can run through the content for rebuilding a RAID array and then sticking that in Captain Nemo. But I just want you to understand, Captain Nemo is Runtime's tool for rebuilding RAID arrays as well, no matter what the operating system is. And so you can just export that content. But they do it through a VIM file, and let's see if I can show you. Well, I don't know if I have the configuration. I do. It looks like this. So basically you would take all your image files and then you would put them in the order that you want to put them in, and then you can stuff them back into Captain Nemo just through an XML file. And so they have methods for building this, so even though their tool doesn't look complicated to do that thing, it is very straightforward and it doesn't have a limit of the number of drives. Here you can keep adding them in the XML file. The RAID Reconstructor tool actually has a limit of how many it can do. So at least in this particular instance you have a process by which you can manually manage Linux and other things. Now there are other tools. UFS Explorer will do all of this on its own, and you don't have to have any of these. So I'm going to talk about RAID, and then we're going to actually do the RAID arrays. But I'm going to start talking about RAID, and then we'll do the labs in the morning because it's already 6:15 and everybody's already tired, right? So we'll do the RAID 0 and RAID 5 labs in the morning, so it makes more sense and everybody's clear, so that they can discern how a picture looks. So RAID arrays. So I'm going to just say, basically I'm going to talk about what a real RAID array is and what a RAID array isn't. Now in my processes, RAID 0 and RAID 5 are the two primary things you'll see in real life. You hardly ever see any other thing except combinations of those. Occasionally you will get a RAID 6. But the idea behind RAID 6 was there was so much money involved and so much redundancy involved that you should never see a RAID 6. But you can use the same exact process to recover from a RAID 6. There is only a slight difference because of one more stripe of parity. And in between that, so everyone wants to talk about RAID 1. What is RAID 1? Is a mirror. So if you have two drives and they are mirrored, you should never see the other drive, right? So, not that you won't, I'm just saying they'll ship them to me, but really I'm only dealing with the one half, right? I'm only dealing with half of whatever it is. So if I have RAID 1, it's a mirror, and I have that. Now, the combinations, so RAID 10. So you have stripes and mirrors. So now let's say it's 4 drives. 2 of those drives are striped, and then they are mirrored on the other drives, right? So you have half of whatever it is. And I will tell you, in real life, I've had to combine one half with the other half in various ways because half of 2 drives died. So one half, one drive died, one half the other drive died. I've imaged them. I've somehow cleaned up all the sectors, sometimes using all the drives to get the right sectors. And then I still only have half. So I don't have to deal with 2 drives after I've got an image. I just deal with the other 2 and put them together. Does that make sense to everybody? RAID 50, same thing. RAID 5, and then they're striped. So you have half and half. So RAID 15, mirrored and striped. So you have mirrored and RAID 5. So you get all of those combinations together. And when you whittle them all away, there's really only left is RAID 0, RAID 1, RAID 5, and RAID 6. That's all that there is in the end. There are a couple of variations of things like Beyond RAID. Beyond RAID is Drobo's version of I will change my configuration whenever and however I feel like it. And that's no joke. It just literally changes. The theory was if I put 3 drives in a Drobo, which is necessary to make a RAID 5, and they're all the same size, then it should automatically configure itself as a RAID 5 because that is the best configuration. Most of the time that's true. But it doesn't look like a regular RAID 5 because it has a configuration portion in front of it. And this is where it really mattered for Reclaim Me Pro. Reclaim Me Pro figured out and reverse engineered how you can actually read those drives in reverse, and it will actually figure out the segments for a Drobo and put it back together. So you still have to fix your drives and image them and get them working again, and then put them in Reclaim Me Pro, and then the Drobo stuff will come alive. It will work. And there's a few others that are like that, but most of them are variations of that. There is one that I believe it's the Netgear one. It does 512 byte stripes. Instead of doing like 2K stripe, 8K stripe, or something like that, every sector is every other sector on every drive. It swaps them. So I'll talk about that in a second, but basically you're just changing your numbers down to something that would be infinitesimal that would normally not show up in any RAID controller, is 512 byte stripes, single sector stripes, one sector stripes. I'm not sure what the efficiency of doing something like that is. Well, why would you do it? But they do. And LaCie is the other one. LaCie is a lot of fun because they are promiscuous, and every night they sleep with a new person, and tomorrow they come in and they have a whole nother idea. I don't know why, but you'll buy a drive one day, 1 week from them. The next week it'll be a completely different configuration for the same drive. I don't know who's making them and why they made those choices, but every week it'll be a different configuration, and I found them to be like 4 different configurations that happen over and over and over again. So RAID is supposed to be, and in my day, because I was there when I heard the term the first time, it was a redundant array of inexpensive drives or devices. And then later on, somehow, now it's become independent. I think people were like, it's not inexpensive. And back in the day, it was only SCSI drives. So they were all expensive. But I just recall it being inexpensive. And I found documentation for both of these. So no one seems to know which word it is supposed to be from that standpoint. Not all of the arrays are redundant. They are supposed to be, they should be, but they are not redundant, even though redundant is in the word. So if a photographer goes and buys a RAID array, and it turns out he did not know that not all RAID arrays are redundant, even though it says redundant array of drives. So that's kind of the real problem. And then there's a different number of drives for an item that you need. Now, what is not a RAID is JBOD, just a bunch of disks. I'm not kidding, this is on the box. When you go over there, there's some dude laughing his ass off somewhere. I created a term, and somehow they got on every marketing box in the entire world. It's on every single box. It'll be, you could make a JBOD, just a bunch of disks. And so they're just concatenated together. So these tools, whatever they're doing, they're just saying at the end of one disk, keep going on to the next disk. Keep going on to the next disk. So they're just a bunch of disks in a row, and they're writing to. They're not a RAID. There's nothing fancy about them. Basically, you take all your drives and you glue them together. That's all you do. You can hand concatenate them. You can copy them together. You can load them into RStudio, and you can say, I've got a segmented volume, and go 1, 2, 3, 4, 5. And here it is. And it'll just treat them all as one drive, because your table for your MFT, your catalog, your operating system is on the first drive, and you need that to access all the content on the last drive. Otherwise, you don't have all the stuff to point to, but they're just glued together from one end to the other. LaCie drives do that. I've described this already, where they have taken an HPA. These are called the LaCie Big Disks. So if you've seen these before, they're still showing up every once in a while. What they did is they took one drive and concatenated it to the next drive by adding in this board all the extra LBA numbers. So it just adds, like this is 500 gigs, it'll add 500 gigs to this. And you put an HPA on the first disk. The first disk will say, I'm 1 terabyte. So you'll have the first disk, if you took it out of the system and you plugged it into your system, it'll say, I'm 1 terabyte, and you try to copy the files off, and when you get to the end of 1 terabyte, or the end of 500 gigs, it just dies, because it can't keep on going to the next sectors. So this board's job was to concatenate those two together. So now, if you had a recovery, let's say somebody, and I've had this happen, they dropped it. And then you get the drive in, the 2 drives in, and you're looking at them, and you open up one of them and it's platter dust. Inside it's completely dead. So let's say the first drive survived and the second drive did not survive. What has he got and what does he not have? What do you have on the first drive if the first drive survived? How do you recover it?
Should have all the file system and everything.
You have the file system, all the metadata. You have the files that are on that drive that are still there that they point to, so it'll look completely fine and normal till you get to that second drive. So now, if the opposite happened, what if you lost the first drive and the second drive is the only one that survived? What do you have?
Carving material.
That's it. You've got to carve everything. So you've got to run a tool that carves and looks for all the headers. And so we're going to do that. Our studio will do that. It's the scan function, and then you can select what you're looking for. But it's going to carve. There will be no organization, file system, directory structure, name. None of that's going to be there. It's just going to be files, whatever was on there. And there won't be anything else. So it'll be dead from that standpoint. So, and so typically at least all the LaCie drives are like this. They are not, especially if you see a board like this that's thin and stupid. If you don't have a processor on it, it could not be doing RAID. So it could not be striping them, right? It has to have some kind of processor, firmware, or something more intelligent than that board. So this one, LaCie also makes NAS boxes, or did make NAS boxes. There's other NAS boxes out there, and they kind of do the same. They look the same. So you know, because you also have a network cable coming off the back of them, there's not a lot of other control mechanisms. This is what theirs looks like. Now, what is this? Yeah, basically it's an embedded PC. It's a Linux box on a card. It's actually a whole computer. It has, on the other side, you can't see everything, but on one side, it's got memory, it's got flash, it's got a CPU, it's got everything it needs, and then it has 2 items for a controller, and that's actually a lot of work for just 2, but it's basically a full-fledged computer, and it communicates over the network. So this is completely your Linux embedded system. So all the stuff I just showed you is actually residing on here. None of those folders exist in the drives. The only folder that exists on the drive is a configuration folder and the user's folder that was shared over the network they could deposit files in. All the other stuff is embedded in a ROM on this board. So I don't need any of this. I only need these 2 drives. Now, in this case, these were also 500 gig drives. My drive now, I cloned it on a DeepSpar. I took this drive and tested it. It was fine. There was nothing wrong with this drive. So I left it alone. I took out this drive, which was 500 gigs, and I cloned it on a DeepSpar onto a 1 terabyte. Then I set the HPA on it equal to 500, because you always have to have on a RAID array the exact same number of sectors. So you got to make sure that they're both exactly the same. So I made this one a 500 gig drive, and surprisingly, because most of the time Linux ignores some HPAs, I put it back in the box and it actually recognized that and allowed it to come back alive, and I could just copy the files off the network. Now, I didn't need to do that. I don't normally do that. There's usually not a good reason to put it back together in the box and let the device change or do anything. If I took both of these drives out and I plugged them into our studio, then this would be in what is most likely the configuration. What is it? What is the organization of the RAID?
1, 2. Oh,
What?
0.
Yeah, it's going to be 0. So RAID 0 is, so here's the thing. When they sell them, they have on the label on the box, you can do RAID 0 or you can do RAID 1. But it comes as RAID 0, and then if you wanted to, you could make it RAID 1, and then it has to reset the whole thing up again. Because RAID 1 would be the mirror, and you'd have redundancy. But when you go to the store and you buy a box, whatever the largest sizes they can say it is what they will configure it as. It's never one of the safe ones. It's always going to be the worst possible choice for safety of your data. So if you go buy a Buffalo Terra station and it's got 4 hard drives in it, what is it configured as? RAID 0. Even if it could have been RAID 5 and it would have been pretty robust, if you have 4 500 gig drives, they're going to say 2 terabyte on the box, right? But if you configured it as RAID 5, how big would it be? 1.5. So that's it. So you're going to lose 1 drive in the process, but it will be safe. It'll be a lot safer than RAID 0 from that standpoint. So all the boxes come as RAID 0, no matter what they are. And this one could have been configured as a mirror, so that this would have mirrored to that, and then you could have saved the day. But no, that is not going to be the way it is, because that would only give you 500 gigs, not 1 terabyte. And the dude probably wants the biggest space he can possibly get when he buys it, because they're looking, oh, I'd like to have a terabyte. That sounds great. So at least in this point, I would have just put 2 of these drives into our studios, done a RAID 0. You pick which one's the first drive. Now, how do you know which drive is the first drive? On all RAID arrays, how do you know which drive is the first drive? Well, there are ways to deal with the RAID signature, and there are tools like UFS Explorer that will solve those with the signature, but way easier than that. I mean, like even dumb RAID arrays, smart RAID arrays, dumb RAID arrays, all expensive RAID arrays, they all have one thing in common that they have to have for all of the stuff to work. What's a requirement for Windows to be able to boot and see its
The FFAA?
Yeah, so it has to have a master boot record, and it has to have a beginning of partition structure. So almost always on all of these, I still see a standard master boot record of 55AA on all of them. So the first drive still has 55AA on it. So if you want to eliminate in the possibility, somebody hands you a stack of 4 drives, and you hook them all up to a hex setter and you look at them, you will find one that will have a 55AA. Not 2, not 4, 1. One will have 55AA on it. Whether it's striped or it's RAID 5. One will have 55AA on it. So that's the first disk, and you put that in place. So if somebody hands you 3, you only have to guess 2 places. If somebody hands you 4, you have to guess 3 places. And it's not that hard to eliminate them, but there'll still be a master boot record, and especially on all RAID 5s, RAID 0s, almost no doubt whatsoever, all the way from cheap all the way up to expensive. And when you get into compact RAID arrays and things like that, they have rotating parity, they have delayed parity, so you may need to try to figure that out. And if you look at a picture, you can figure it out, and you can do it by hand. You just don't need to, because there's already a configuration on the drive, and you could just have a tool look at the configuration and tell you what it is. Because they will. They'll tell you the order of the drive, they'll tell you the serial numbers. So, but you may not know that in the mystery box. The mystery boxes are dumber, and the mystery boxes like Adaptex, AMI, High Point Controller, all those others, everyone, there's only 4 primary configurations. Believe it or not, in RAID, everybody's been telling you all this stuff all the time, like RAID really hard, there's all these options. There's only 4 primary configurations. And then anything that's really expensive, Compact, IBM, JFS, they do have their own configuration, but there's only one of them for those guys. So HP Compact has one set, and it's a delayed parity. It's still basically exactly the same as every other RAID, just one extra row. So there's not a lot of variation, not as much as you would think. It's the drobos and the weird people who are millennials out there writing code that's screwing things up. They're the ones messing things up. But there's only 4 primary RAID configurations. All the others are just customized for some sort of, like NetApp is a customized one. But anything that you see that's a PERT controller, a Dell, any of those, everything from there on down is a breeze. They're all the same. There's only 4 choices, and that's it. So, in this one, basically same kind of thing. If it died and it was RAID 0, what do I have? If one drive dies and I can't recover from one, what do I have? Nothing. I have half of every file. So maybe if your slice size was 256, maybe every file that was 256 that fit on there, maybe I get lucky and I get some 256K files or less. That's it. There's no PST, there's no nothing. Maybe I get a couple of JPEGs, some thumbnails, 32K thumbnails, but that's it. You won't see anything else that you can use because none of the files that are large enough are going to be usable. You have half of everything. So we'll get into that in a second here. Dynamic disks. Microsoft came up with this great idea. Let's do this dynamic disk where we just put a configuration at the end and we just keep concatenating drives. They're very easy to do. I made a movie on how to do them all. It takes about 10 minutes, and RStudio does them all automatically. You just take all your disks after you've recovered them and you just feed them into RStudio, and RStudio will find a configuration and tell you the order. And it's all done for you. You don't even have to do any work. Literally repair the drives. That's your work. All your work in the front end is all repair the drive, clone it, get it running, fix all the sectors, put it into the software. So it's very easy. All right, so now let's talk about the RAIDs themselves. RAID 0, RAID 1, RAID 5, and RAID 6. And I'm going to get off of these crappy pictures in a minute and use something else. But RAID 0, what's the minimum number of disks normally for RAID 0? 2, right. What is the maximum number of disks for RAID 0? What? What?
As many ports as you have.
As many ports as you can get. You can just keep doing them and doing them and doing them. And it sounds asinine, but because RAID 0, you're just asking for a nightmare. Just asking for something, because no matter what, one of them dies, you lose a section of every file that you own. I have done RAID arrays with 14 drives in them that are RAID 0. I don't know why you would do it, but they do it. I have seen them up to 72 drives. I have seen systems running on RAID 0 with 72 drives.
Think of the performance.
It's great. It's great. I do see them a lot in like studio stuff. Like Sony would have them for compiling. You know, if Babylon 5 is going to come back, they're going to make some nice renders, and they're going to move just as fast as they possibly can, and then back them up. So the theory is they're going to back them up. They don't always back them up. So, and if they die during the render, then you have to recover them. It comes up. Anyway, so same thing with RAID 5. We're going to skip RAID 1 for a second. RAID 5, what's the minimum number of drives in a RAID 5 array? 3. Do you know this stuff? Is this the kind of...
Yeah, we deal with 0.
Okay, you do.
Speed,
Yeah, you got backups?
almost the same as
Okay, all right, good. All right, you're about to cause me a heart attack here. It's like, oh man. All right, we need to re-examine your systems. We'll lay them back out again. like I've had those discussions. People are like, what are you doing? Don't do that. RAID 5, minimum number of disks is 3. RAID 6 is 4. So they add one more drive and they distribute parity. So it's redundant. There is no more space added to your array. RAID 6 is now your safety net. It used to be RAID 5. Drives are now crappy as all get out. So no one uses RAID 5 by itself anymore. People are all moving to RAID 6 because if one drive dies, the other one dies within 24 hours, you're SOL. And it almost always does these days. These days, that's a pretty good sign the next drive's going to go. So RAID 6 is not really different than RAID 5 from a functionality standpoint. It just adds another stripe live in the system so that the system can live another day longer. All right, so what's the maximum number of drives in RAID 5? It's the same answer. It's a trick question. It's the same answer. As many as you can keep plugging in. And you don't even have to have them on the same controller. In many cases, you can combine controllers together. And you can say, I'm going to select all these drives and just keep adding them. And so again, 72 is a pretty easy possibility. But I've seen more than that. And most of the bigger arrays and SANs and stuff like that, they're up to 80-ish drives at this point. Is kind of about how big I've seen it. I don't know if I've seen more than 80 drives, but that's about the extent of them. I've definitely done 64 before in a recovery. All right, so now RAID 0. RAID 0 is not redundant at all. It is there completely for speed, and it takes a slice of every single thing and breaks the slice up. There's zero redundancy, no math going on, no nothing. I feed it a file, and at the beginning of a JPEG, if you think of I'm pouring a JPEG out of a cup. So if I've got a JPEG, and here's the picture, here's my head, here's my feet, as this pours in, it's going along in each one of those stripes. So the first drive's going to carry the first stripe, the first 32K, 64K, whatever size I choose. Then the next piece is going to be the next piece, and so on and so on and so on, and you're just going to keep pouring until it fills it up. So if any of those slices die, you've lost a piece of your picture if your picture is big enough to make it across the number of drives you have. So if you have a slice size of 64K and you have a 2 meg picture, then somewhere around 8-ish or whatever drives, you're going to lose any part of the picture that you would have had after that. So since they all go in a cycle and they loop back through, you always lose it. PST files would die. Nothing big would survive. Only the small stuff would survive. There's no redundancy, and what I think should happen is we should all band together and rename RAID 0 AIDS. It's an array of inexpensive drives that suck. So that's the way, and a lot of, it's fine if you want to use RAID 0, I just don't think you should be, well, it is only for temporary. If you don't back it up, then you're in trouble. But other than that, I agree, you have AIDS. So, it's going to die sooner or later, and when it dies, it's going to take you with it and everything that it owns with it, and it's not going to survive. So, I know it's a terrible joke, but that's the way it goes. Anyway, so, again, there is no mystery to this. This is literally straight up the easiest thing that you can possibly ever do. And after you do RAID 5, RAID 0 seems infinitely easier. Even with graphics and pictures, I almost don't care how many drives you give me. I can figure it out because it's a puzzle, and it really doesn't take that long for me to figure it out. And I'll explain to you why in a minute. It's very easy. And so there's all these people that go through all these calculations to try to tell you how many you have, if more drives, you have 72 combinations. You don't really. You don't. So you always know which one's the first drive. So you've only got to swap 3 other drives. The only thing that you've got to worry about is the slice size variation. That's it. There's nothing else to worry about in a standard RAID 0. And I'll show you why. First drive, you know where your MBR is, and it really just depends on your slice size and how small or big that the slice size is. And there's a limited number of them, so you can still guess them, no matter what they are. You can figure them out by looking at the drive with the hex editor, but I don't need to. I promise you I could solve almost any of the RAID arrays in under 45 minutes, without a doubt. Even RAID 5. Most of the time I can solve them under 45 minutes. Now, exporting the data, that's a different story. Like, I only want to figure out the configuration. I want to be as fast as I can at figuring out the configuration. I don't want to build trees. I don't want to look at directory structures. I don't want to look at any of that stuff. All I want to do is carve pictures. That's all I want to do. If I just carve pictures very quickly, I can do 6 to 10 tests in 45 minutes. And in that amount of time, I can tell you which one's going to be the most probable that's going to work, and then I can solve the problem. Does that make sense to everybody? So I'll show you how I do that from that standpoint. So I'm looking for the MBR. I'm looking for the string. Even if I have a complicated RAID array, what's complicated about it is the beginning of it has a configuration, and then they slipped your data. So you still have an MBR, you still have a NTFS structure, you just have to find out which one has the beginning of it on it, and then you work from there. And then you can start looking just for pictures and carve them out. Now, it used to be people would do a headless Linux server, and there would be no pictures on it. I can't even tell you the last time I've never seen a server that didn't have pictures on it. Everything's got pictures on it. It's got boot pictures, it's got user data pictures, photos everywhere, everything has it on it. Nothing doesn't have it at this point. So, and then the only thing you have to do is figure out what your boundaries are for your slice sizes. Now, this isn't the whole list. Turns out you can do 512, you can do 1K. Then you do 2K, 4K, 8K, 16K, 32K, 64K, 128, 256, 512, and 2 megs. That's it. So that's all your choices. I will tell you, in all my experience, in all the ones, I've never seen one above 512K and then 512 bytes. So I've seen all of those in between. Almost no one uses 1K, 2K, 4K, 8K, or 16K. Almost none of those ever happen. It's always 32K, 64K, LaCie drives are 128K, 256, and the LaCie drive has also been 512. So all of these have all been LaCie drives. I've never seen any I can think of that somebody made it on purpose that size. There'd be no point in it. I don't see what the point is even now. Like, why is that going to add any speed or do anything to you? 64 is the default for almost every drive, both RAID Array 5 and RAID Array 0. Almost always 64. So unless you got a guy who's just playing with it, then, you know, and I see IT guys do that all the time, then I'll make it 32 or whatever else. Some database guys who know what they're doing can actually make it work better. So when I start extracting pictures and I start reviewing pictures, this is what they look like. So the first one. So when I first started teaching this and I threw this picture out there, I said, so what's wrong with this picture? And some dude in the back goes, nothing. It's like, alrighty. So what is wrong with this picture? Anybody know what's wrong with this picture? What is my drive configuration probably?
Well, that's probably the last one at the bottom.
What? No, what? I mean, what is it? What is it?
RAID 0.
Oh.
Is it RAID 0, RAID 5? How many drives? What do you think it is?
Yeah, probably 0.
Yep, RAID 0. And what's wrong with it? How many drives are there?
Probably 3.
Okay.
Or 4.
Like 3 there, but there should be another.
Well, There's actually only 2 drives, and that's why the middle piece is missing. It's actually, otherwise you would have had head, maybe